Hello and welcome. Thank you for joining us for the EVs Are Coming, Are We Ready? Joining us today is Eric Wood from the National Renewable Energy Laboratory, or NREL, in Golden, Colorado. I'm Amy Luft, the Communication Coordinator at Compass. Compass strives to reach out to all residents of Ada and Canyon counties. Please help us track how well we are doing by participating in the poll on your screen. Responses are anonymous and your participation is completely voluntary. We really appreciate your help. As the popularity of electric vehicles, or EVs, continues to grow, so does the need for the infrastructures to support them. Are we ready here in the Treasure Valley? Today we'll explore what's needed to build out EV charging infrastructure in Southwest Idaho, and what steps it will take to get us there. As I mentioned, today's presenter is Eric Wood. Eric is a senior engineer at the NREL, leading EV infrastructure projects in California, New York, and on behalf of the U.S. Department of Transportation nationwide, Department of Energy nationwide. Working in NREL's Center for Integrated Mobility Sciences, Eric has a decade of experience integrating real-world travel data into the analysis of vehicle, infrastructure, and energy storage systems. He has a background in mechanical engineering and enjoys working at the intersection of automotive, transportation, and power sectors. A few housekeeping items before we start. For good sound quality, all participants have been muted. As you have questions, please type them in the chat box, and we will be pausing periodically throughout the presentation to address those questions. In addition, this presentation has been approved for 2 AICP certification maintenance credits. We will also be recording this presentation and we'll be presenting the recording later on Compass's YouTube channel. I'll also follow up at the end with an evaluation that I will send out to you after the fact that will include the slides from today's presentation, so you will have that information as well. Please do remember to complete the poll on your screen and enter your questions in the chat box. And with that, I will turn you over to Eric.
Thanks, Amy. Hey, everyone. Appreciate the opportunity to visit with you all today. Hoping for an interactive crowd today, so please do take advantage of the chat to throw questions out there, and we can discuss those as we move through the presentation here. So just a quick rundown of what I'm hoping to cover today. So EVs, what's all the fuss about? Charging as a philosophy, trying to think about charging as a better alternative than gasoline or what people are familiar with. Certainly want to spend some time talking about financing for these stations. Show me the money. What is all this going to cost? What are some planning resources and tools that are out there to make sure that we measure twice and cut once? We'll talk about a little bit of the modeling that we're doing at NREL to support some of these planning activities at the national level, including with the Department of Energy, and show a preview of some results specific to Idaho. And then we'll wrap up talking about heavy-duty electrification and some opportunities and challenges that are out there for the industry right now. So what is all the fuss about? So as we look to decarbonize our economy, transportation is a really big contributor to the national GHG inventory, or greenhouse gas inventory. So about 29% of greenhouse gas emissions nationally coming from the transportation sector. And transportation is a relatively monolithic sector. So petroleum being primarily and dominantly the energy source of choice, both for light-duty passenger vehicles, pickup trucks, as well as medium and heavy-duty vehicles. So really that light-duty segment is what we're going to talk about a lot today. That makes up almost 60% of emissions in the sector. And so EVs are a really exciting technology solution to help reduce those greenhouse gas emissions. And we're seeing a lot of momentum for the technology right now as well. So major automotive manufacturers have made announcements about shifting towards electric vehicles, including investments in R&D and manufacturing for the vehicles and the batteries critically. It was actually about a year ago, the Super Bowl last year, General Motors debuted this commercial where they brought in some big Hollywood stars to help advertise for electric vehicles. In my mind, that was one kind of signal that this momentum in the industry is really in a turning point right now. When you see these companies actually spend real money on advertising and trying to get consumers excited about the technology. So that's certainly something that gets us all in the industry excited. We're also seeing a lot of private investment in electrification, and so some of our colleagues at a consulting firm called Atlas Public Policy actually track private and public investment in EVs and charging infrastructure. And this slide actually is a little bit dated, but even at the time, about a year ago, we were north of $400 billion of global investment from across 60 companies in the space of EVs, electrification, and charging infrastructure, and that has really only grown, over the last year or so. So a lot of interest, and that interest being expressed not only in the press, but with people actually putting their money where their mouth is, so to speak. The story of Tesla, right, is also a really interesting story, and a sign that there's appetite for this transition. So this is another slide that's a little bit dated. Tesla's market cap right now is on the order of $1 trillion, and so it's really just a remarkable evaluation for a company of its size, and given that Tesla manufactures much smaller volumes of vehicles than companies like Toyota or General Motors or Honda, the fact that they're able to have an evaluation from Wall Street at that level is really telling, I think, regarding where perceptions on where this industry is headed. So very exciting there. A lot of the developments that we've seen in the EV space have been enabled by rapidly decreasing battery prices. And so, about 10 years ago, if you were going to purchase an automotive grade battery pack, you'd be paying about $1,000 per kilowatt hour, where a kilowatt hour is a unit of energy that can be stored in that battery. Today, that value is much closer to $100 per kilowatt hour, and forecasted to continue dropping through the next decade and out to 2030. So as the battery costs continue to come down, what that means is that these vehicles are increasingly seen as profitable and attractive for the OEM or the manufacturer to sell to consumers. And there's certainly a lot of interest from the consumer side as well. So we're seeing a lot of new models and chassis types coming online with electric options today. The pickup truck is iconic in America. And so seeing a startup like Rivian or companies like General Motors and Ford come out with some of their legacy products as electric options is really exciting. The performance that you see with these vehicles, the lack of tailpipe emissions, and the affordability when it comes to maintenance cost for these vehicles are all really exciting developments and things that consumers point to. So this excitement, really, what does it mean for the industry? So there's about 2 million electric vehicles on the road today in operation. A little over half of those today actually come from Tesla. So Tesla's been very dominant in the sector. We also see about 40% of the electric vehicles on the road as plug-in hybrid electric vehicles. So these are vehicles that can operate on a battery exclusively for a short distance, and then have a gasoline backup for hybrid operation after that. But the makeup of the plug-in fleet in the US is expected to change over the next decade. First and foremost, increasing in size. So President Biden has put out an executive order along with a lot of the domestic manufacturers targeting 50% of new sales as zero emission vehicles by 2030. If the industry is able to meet that target, which admittedly is an aggressive target, we'd be looking at somewhere around 30 million vehicles on the road in 2030 that were electric vehicles. And so the composition, or the way that the industry is kind of expected to shift, is that we're expected to see a lot more fully battery electric vehicles, fewer plug-in hybrids, I think most of us would certainly expect Tesla to continue to play a large role, but increasingly seeing more of a presence from their traditional OEMs as they pivot their offerings to battery electric and plug-in hybrids over the next several years. So all of this demand, right? The question becomes, where do you charge all of these vehicles? How do you keep these tens of millions of vehicles fueled on the road and providing the mobility service that consumers are accustomed to and expecting? So as part of that puzzle, the recently passed bipartisan infrastructure deal is scheduled to invest about $7.5 billion to build out the first ever national network of EV chargers in the United States. This is something that is intended to provide full coast-to-coast mobility for electric vehicles, something that is really have a particular focus on disadvantaged communities, rural areas, and hard-to-reach communities. So developing EV infrastructure is a very challenging endeavor. And so having these public funds available to help accelerate the process is something that I think the industry is very excited about. It's generated a lot of interest across the country. So when we think about EV charging, one of the things we talk about often is this idea that we want the experience to be better than what people are accustomed to. So superior experience. Now, what does that mean? So the goals for a national charging network, really, in my mind, it's a network that needs to be convenient. That means you need to be able to access it. Payment needs to be transparent and easy and understandable for people. The price to charge needs to be affordable when you're using that public network. We need the network to be reliable. So when you go and show up to charge, you know you're going to be able to get a charge with a high level of confidence and not have to wait in line to do so. And then we want the network also to be accessible and equitable for all communities. This is not a technology that's intended exclusively for the wealthy. It's one that we think has a lot of potential benefits for all Americans. And so realizing those benefits means that the network needs to be designed in an intentional way. So who are the stakeholders, right, involved in the development of this network? So certainly, first and foremost, current and future EV drivers. We need to try and understand what needs people have for EV charging. What are the use cases for charging, and how does it fit into their life? The automotive OEMs are certainly an interested party. A lot of their profits and plans over the next decade really hinge on having this national network of charging that their customers can rely on. EVSPs, so electric vehicle service providers. These are companies like Electrify America, ChargePoint, EVgo. These are the companies that own and operate and maintain publicly accessible charging infrastructure. They're in a very unique situation currently. The economics of trying to run a charging network today are very challenging. And so the grant programs that are going to be coming out from the federal government later this year are really intended to help support these companies and help them bridge what we sometimes call the valley of death, which I'll talk about more in just a minute. An often overlooked party in this network are the site hosts. And so the charging network companies, it turns out, often don't own the real estate or the land that charging is made available on. So if you go to Walmart or Target or Whole Foods to plug in and charge your vehicle, it's usually the case that those companies don't actually own the charging equipment. It's a third party that comes in on that private property and makes a publicly accessible charging infrastructure available. So thinking about what the incentives are for site hosts to facilitate charging at their places of business as an amenity potentially for customers is a really important piece of the puzzle. And then, of course, electric utilities are really the linchpin, right? They're the ones that are actually bringing all of the power to these stations and making sure that they're energized and well integrated with the rest of the power system. So EV charging as not only something that doesn't break the grid, but something that can be a resource for the grid in terms of additional electricity sales and putting downward pressure on rates for all ratepayers is something that we think is very important. And so there's a lot of perspectives on what this national network should look like. There are people that would look at gas stations today and say, EV charging should look like that. We want to be able to pull in and leave as fast as possible, at a small number of stations around an area, and have the experience be similar to what people are familiar with. There's other ideas, right, that stress the importance of being able to charge overnight at home. There are a lot of folks that believe that home charging is really the most convenient and affordable type of charging out there. It's something that I've heard people say takes no time at all, right? You plug the vehicle in, then you go inside, and when you come out the next day, it's fully charged and ready to go. And so gas stations, charging at home, and then this idea of what we sometimes call an EV happy hour. This is an idea of vehicles being able to slowly sip electricity, if you will, at a lot of the different places that they visit during the day, including at work, at retail and recreational locations. This potentially has advantages for the electric power system, as it makes the load or the electricity that's supplied to electric vehicles much more flexible when you give people lots of options of when and where to charge. So these are all different kinds of ideas for what a national network could look like. Let me just pause there for a minute, Amy. I'm going to just see if there's any questions yet that have popped up for folks.
Thank you, Eric. Yes, we do have several questions. I also am going to take a moment and launch the poll that I had open earlier. I apologize. It accidentally closed and cut off most of you. So I am going to relaunch that. If you wouldn't mind, please taking the poll. It just gives us an idea of who is visiting us today and helps us make sure that we are reaching out to everyone in our region. So I'm going to relaunch that. And then, Eric, I'm going to share some initial questions. The first couple have to do with the batteries themselves. First question is, what about the toxic chemical waste from manufacturing the batteries and mining the lithium and other materials used in the batteries? And then a related question deals with the rare earth minerals that are used in the batteries and how soon that technology might need to come into more commercial production.
Yeah, certainly. So I can speak a little bit to that. So, when we look at electric vehicles on a life cycle basis, or, from when all of the raw materials are mined until the end of life of the vehicle, we typically find that the operational efficiency or the driving efficiency of these vehicles is at such an advantage relative to combustion vehicles that even given the challenges on the front end and the back end of the life cycle with EVs, they do tend to come out with a lower greenhouse gas footprint and environmental impact than a conventional gasoline or diesel vehicle. Now that said, trying to minimize both those front end and back end environmental challenges with EVs is an active area of research nationally right now and internationally. So on the front end, there are a small number of materials that go into lithium-ion battery packs to power EVs that come from relatively politically unstable regions of the world. And so, the electrochemists that are developing the next generation of lithium-ion technologies are looking at ways to reduce or eliminate some of those more problematic materials, namely cobalt, that comes from different parts of Africa. And so the materials that go in on the front end are part of the equation. On the back end, there's a lot of work going on right now on how to recycle these batteries and make them available either for a second life, for a grid storage application potentially, or repurposed entirely and fabricated as a new battery pack for a new electric vehicle. So it's really that circular life cycle is the emphasis right now in a lot of R&D circles. And so, I think there's good work going on there, and it's definitely a point of emphasis for the industry.
Thank you. Another question deals with the rural nature of Idaho. noting that many areas even lack self-service coverage, much less electrical service. So how can a charging network deal with such a large rural state with a lot of areas that are backcountry and with unpaved roads?
Mm-hmm, mm-hmm. Yeah, we'll talk a little bit more about that point here in a minute. There are some technology solutions that are available for more remote areas when it comes to charging, and so some of those include distributed generation and storage of electricity, and so charging stations that could be solar powered potentially in a remote location with a battery on site to make sure that charging is available when vehicles arrive is one solution that we've seen in remote areas. And the rural nature in general makes the development of the network really challenging. So I'll talk in a minute here about this idea of coverage versus capacity. And so what you find is that in rural areas, you end up needing to develop a lot of infrastructure to cover a lot of ground, but that infrastructure tends not to be utilized at a very high rate, which is challenging from a financial perspective for these companies that are trying to turn a profit providing EV charging as a service. And so what we find, yes, is it kind of creates this valley of death, if you will, where we need this infrastructure available in order for people to consider adopting the technology. But until the infrastructure is utilized at some minimum level, we find that it's very challenging for the charging network companies to maintain the infrastructure and turn a profit.
Next question shifts gears quite a bit, and I was wondering about the outlook for individuals that are going to be needed to maintain and repair. I assume you're talking about the charging stations as opposed to the vehicles themselves, but that skill set and training on that skill set.
Yeah, it's a great point. So I would say that to date, maintenance of charging infrastructure has not received enough attention. There's actually a company being that's growing right now in California, and you can Google them if you want, called Charger Help with an exclamation point at the end. This is actually their sole mission, is to begin developing a workforce and the skilled technicians that are necessary to diagnose, repair, and maintain this charging infrastructure. What we've seen in too many cases to date is this infrastructure being installed, going in, energized, and then not having really anyone that's accountable for that infrastructure's maintenance over time. And so you'll find things like charging stations that are infested with wildlife or overgrown by vegetation in an area, or a snowplow will come and knock them over, and there's no one around to repair or fix that station. And so what Charger Help and some similar companies are looking at right now are ways to kind of build into the front end of that investment funds for maintaining that throughout, say, a 10 or 15-year life for that charging station, so that it's online and available, and something that people can rely on. You certainly don't want to look up a map, see a charging station along your route, and then show up and find that it's out of service or in ill repair. So maintenance is really a critical piece there. Electricians are definitely a needed skill set in this topic area, but also software technicians. It turns out that a lot of challenges with charging station reliability just comes down to the software and needing to make sure that there are regular updates being made to diagnose any problems that come up and make the station inoperable. So a lot of need, I think, in that area going forward.
Next question is about taxing. If there's been any serious discussion about incorporating the collection of taxes into charging sites, similar to what we do now with gas at the fuel pump.
Yeah. So, as most of you probably know, highway infrastructure or roads are really financed in the U.S. with gas taxes, either at the state level or the federal level. That's something that has been increasingly challenging for DOTs over the last several decades as vehicles have become more efficient. They're still putting wear and tear on the road, but they're using less fuel and thus paying less for gas tax. So financing for highway infrastructure has been a major challenge for a lot of DOTs. There are ideas right now about different ways to recoup those funds as we see more vehicles turning electric. Directly taxing the electricity is kind of one idea. There is also this idea of maybe a mileage-based tax, where based on how many miles you drive each year, you are required to reimburse the state for those miles. So different ways, and there would be like different levels of technology that would go into how you monitor and report those mileage estimates. But it's definitely a challenge and something that I think people are really looking into right now.
Can you talk about the role of battery storage, both for leveling out electric power demand and vehicle to grid integration in both directions?
Yeah. There are some slides in a little bit on storage specifically, but that's exactly right. So one of the main financial challenges with these stations are that they tend to be low utilization, especially in early days. And as a result, a big part of the electricity bill that the station owner sees is for what's called a demand charge. So this is a fee that the electric utility levies based on the maximum amount of power you consume in any one short duration interval during the billing cycle. And so that demand charge ends up being a very challenging expense for the station owner operator. They're not really able to pass that expense on to their customers in a direct way. And so one way, a technology solution for overcoming that challenge is to install an on-site battery or a storage device where you can charge that battery at a low rate and then use it to help smooth out those peak demand events. That keeps your utility bill much more reasonable throughout the month and generally helps with grid integration as the question was posed.
So Eric, we do have many more questions that have been posted in the chat. I do want to make sure though that you have time to get through your presentation that you had prepared. Would you like to keep going with questions in the chat, or do you want to jump back in and hold those for later?
I'm fine going a little bit longer on questions. Certainly want to talk to the things that people are interested in, and we can get to the slides, here in a few minutes.
Okay. Next question actually tags along well with what you just answered about the batteries, and this is the state of the battery recycling technology and the processes, and if there are any policy incentives.
Yeah. So in general, I would say that the EV industry is still in a pretty nascent stage, right? And if you look at recycling, you have to kind of wind the clock back, say 10 or 15 years, and think about how many vehicles are really coming to the end of their useful life today. And the answer is there's just not that many vehicles that are available for scrappage or recycling today. And so we really haven't seen a lot of recycling policy yet, and certainly not an industry at scale for recycling these battery packs. Again, the real challenge there is that if you look at how many vehicles were sold new, say in 2011 or 2012, we were really looking at small volumes. And so those are some of the vehicles that are coming closer to the end of their useful life today. Hopefully those vehicles can stay on the road for many years still, but I think we're going to be 10 to 15 years delayed behind the new vehicle market when it comes to developing industries for recycling.
So a similar question, that an EV will far outlast its battery, or actually more of a comment, if having an economically viable way to replace or refresh that battery could help prevent from having those scrap vehicles. So just kind of tagging on with it, what you were saying.
Yeah. So this is kind of like what some people will call a skateboard concept, right? So what you'll see with a lot of EV designs is that the batteries will be laid out in almost like a skateboard type architecture, where they're under the frame or the chassis of the vehicle, really low to the ground. That helps with center of gravity and acceleration and stability and all sorts of things. But you can imagine, right? Taking the the chassis of the vehicle and disconnecting it from the frame and the battery pack, and swapping in a new battery pack, say after 10 or 15 years of life. That is something that's been discussed. I think a lot of that concept is still relatively theoretical. It turns out when someone goes to the expense or effort of buying, say, a brand new battery pack, they tend to enjoy or appreciate that new car smell, if you will. So I don't really have an opinion, to be honest, on whether the skateboard concept or replaceable battery packs will gain traction in the industry, but it's been more of a theoretical idea to this point.
I had a couple of comments in here that I misinterpreted the question about the repair and the kind of the bandwidth for that. The question was about the infrastructure, but more actually was about the vehicles themselves. But also just a request, if you could repeat again the name of the California group that is doing the infrastructure maintenance.
Yeah. So if you Google charger help with an exclamation point at the end, you should be able to find that company. It's a really exciting company in my mind because, like I said, I think maintenance and reliability has not received enough attention today. And as we look to scale the industry for charging, having stations that people can count on and rely on, I think is just going to be super critical.
I think we look like, actually, I think looking at the questions that we are probably at a good stopping point. So I will turn back to you to continue on with your talking points.
Sounds great. We'll till a little bit of new ground here and see what questions that crops up for people. So for those that have spent any time in this kind of industry, this is going to be a really familiar visual. So for many years now, charging for EVs has really been visualized using this charging pyramid. And the concept behind this pyramid is really to try and maximize the use of low cost and inexpensive charging at convenient locations as much as possible. And so you see, at the foundation of the pyramid is home charging. It turns out that most people, sleep many hours a day, right, at a home location overnight. And that turns out to be really an ideal time to charge an electric vehicle. Several hours in a row where the vehicle is not going anywhere, doing anything. In the US, we're fortunate enough to have a relatively mature power system for generating and distributing electricity to people's households. That's not to say that upgrades aren't necessary for certain households, but there's just a huge head start for EVs when it comes to fueling infrastructure. If you look at hydrogen or other alternative fuels, the ability to conveniently charge overnight or fuel overnight at home is not a common feature for other alternative fuels. And so EVs are really unique in that way. This charging pyramid kind of rounds out, though, with workplace being another kind of ideal location for charging for those that do use a vehicle to commute to work. In a pre-COVID environment anyway. Maybe at work for 8 to 12 hours or something a day. Another really good opportunity for charging. However, not everyone can charge at home. We know not everyone uses a vehicle to commute to work. And so the presence of a public charging network is still a really critical part of the network. This would include relatively slow charging that takes on the order of hours, as well as fast charging that can be completed in a matter of minutes. So we talked a little bit about the Valley of Death. Here's the Valley of Death figure. So this is a concept that we developed at NREL to describe these different roles for the development of a public network, thinking about both coverage of infrastructure and capacity of that infrastructure. And so the way that we like to think about this concept is that in a very small vehicle market, or if there's not very many vehicles on the road, as has been the case in the early days of EVs, it turns out that there's still this minimum level of coverage infrastructure, this dotted blue line, that's necessary in order for people to see or to consider these vehicles as a truly competitive replacement with what they're driving today. And so being able to, get to grandma's house, national parks, travel on cross-country road trips. These are all the things that are really necessary from a coverage perspective. Now, there's another dimension here, which is really thinking about how much demand for public charging is out there at any time. And that one is a function, if you will, of the size of the EV market in a given region. And so as more vehicles are sold and come on the road, we would naturally expect the frequency and the amount of demand for public charging to increase over time, particularly as the secondary market develops and we start to see more individuals that are unable to charge where they live or at their home location. We would expect that the role of the public network is going to be elevated for those individuals. And at some point, that demand for charging catches up, if you will, to that minimum level of coverage that you need in order to have a successful system. And so at that point, then you're back in kind of this very market situation where you can monitor the demand of charging by looking at utilization of existing infrastructure and continue to add to the supply of new infrastructure, excuse me, in order to kind of achieve that market balance, if you will, of supply and demand for charging infrastructure. This idea of demand and coverage applies both to the communities where people live, small towns, large cities, as well as along the highway corridors that people utilize for long distance travel. That corridor infrastructure tends to be a relatively challenging piece to develop, but the needs on a absolute basis are much smaller than what we would typically expect to be necessary within the communities where people live, work, and spend most of their time. And underlying all of this is the idea that home charging is foundational. Today, most EVs do most of their charging at home, but in the long term, we would expect the share of EVs without access to home charging to increase, particularly as adoption picks up in the secondary market among renters and folks living in apartment buildings without access to off-street parking. Those are really going to be the things that push the demand for more public charging. A little bit of terminology for charging infrastructure. So you'll see that there's often a lot of misuse or confusion or at least inconsistent terminology. At NREL, we really try to conform to the Department of Energy's Alternative Fuels Data Center in their nomenclature. So this is just a screenshot that I've taken from that website, the AFDC. And so what you really see here are these kind of three different levels of infrastructure. So a station is defined as a physical location where public charging is available, similar to a gasoline station, if you will. Now at a charging station or at a gasoline station, there are multiple ports or multiple pumps in the case of gasoline that are capable of filling more than one vehicle at a time at the station. So typically we say that a port is capable of charging one vehicle at a time. Now at a gasoline station, you might find that a pump has multiple nozzles for different grades of gasoline or maybe gas and diesel. EVs are similar in that some chargers are equipped with multiple connectors that are designed for different types of electric vehicles. And so one port could have multiple connectors. And so in the example on this slide, we're looking at one station with 3 ports and a total of 4 connectors, where the first 2 ports are single connector ports, and then the third port on the right is actually a dual connector port. The connector standards that you see in the market today come at different grades or levels, I would say. And so typically we talk about charging in terms of level 1, level 2, and DC fast charging infrastructure. So level 1 infrastructure actually uses 110 or 120 volt electricity as a source. And this is going to be the lowest grade of charging that's out there. So you'd be looking at recouping, say, 2 to 5 miles of range for every hour of charging using a level 1 connector. This can be a good solution for folks at home or folks that have short range electric vehicles. But more often than not, you will see level 2 as a more popular solution, both at home and at workplaces, I would say. Most of the public infrastructure that's been developed today is either this level 2 in the green box or the DC fast charging infrastructure. So a level 2 can recoup, say, 10 to 20 miles of range per hour of charging. So you'd be looking at getting a full charge on a 200-mile vehicle overnight, essentially using a level 2 connector. Both a level 1 and a level 2 connector use the same interface. So this is a J1772 port. The difference being that the level 2 infrastructure is really using 220 or 240 volt electricity as the source, while level 1's relying on a common wall outlet essentially. And then there are 3 different kinds of connectors for DC charging today. This is direct current charging. This is charging that uses 3-phase power as a source, at a 480 volt transformer typically. So today there are these 3 connector types: a CCS connector. This is common for American made and European vehicles. And even increasingly, we're even seeing a lot of the Japanese and Korean companies migrate to the CCS connector. The CHAdeMO connector is the next one. That's one that appears to be being phased out right now by much of the industry. Nissan was one of the champions of the CHAdeMO connector over the last decade, but they've recently signaled that they're also moving towards CCS. And then the third is the Tesla connector. So Tesla actually developed their own DC connector kind of in parallel with the development of these other connectors. And so they're currently islanded or isolated from the rest of the industry right now in terms of the type of charging equipment that they use. DC fast charging, kind of historically speaking, was able to recoup about 60 to 80 miles of driving range in about 20 minutes of charging. But I put a note on this slide that really is in the context of 50 kilowatt DC fast charging. So that was kind of the standard for many years, was fast charging at a rate of 50 kilowatts. Today we're seeing infrastructure being installed though at the 150, 250, and even in some cases 350 kilowatt level. That allows vehicles to charge much faster than what's shown on this slide, with a lot of the industry really looking at a 10-minute full charge as a future goal of where we'd like to get to. Part of the challenge there is the speed or the power of the infrastructure, but another big part of the challenge is the battery and what the vehicle can actually accept. And so, if you take a Ford Mach-E to a 350 kW charging station today, you might only be able to get, say, 150 kilowatts into your battery at one time, or at a max rate, and in some cases even slower than that. And so the infrastructure, I would say, maybe is a little bit ahead right now of the vehicles and the battery technology in terms of charging speed, but there is a lot of research going into that area right now. Let's see here. I'll just go maybe one more slide, and we can invite some questions if there are any, which would be great. I'll just throw this one up here that shows, in addition to the 1772 connector and the DC connectors I showed on the previous slide, there's some other connectors that are either developed or in the development process right now for charging vehicles either internationally or using connectors for heavy duty vehicles that are able to provide larger power levels, even looking at up to megawatt level charging. So go ahead and pause there, Amy.
Great, thank you, Eric. Actually, a couple of questions related to what you were just talking about with the different types of connectors is if you foresee that eventually there will be any sort of standard protocol that says this is what we will use, or if that will be more maybe market driven. I think especially with Tesla having really kind of gone their own route.
Yeah. So the European model actually, several years ago now, they went ahead and took a strong position around a version of the CCS connector. So over in Europe, you'll see what's called a CCS Type 2 connector. And that was the connector that was regulated by the European Union several years ago. In the US, we've taken much more of a hands-off approach or a market-based approach. And that has led to some of the splintering. Like I said, I think CHAdeMO is really being phased out right now. And so what we expect to see is really Tesla to continue to maintain their proprietary connector and network, and most of the rest of the public infrastructure really gravitating towards these CCS Type 1 connectors. It'll be interesting to see when the Department of Energy releases guidance later this year on program requirements. If they take any position on the eligibility of these different connector types for funding. I think it's really kind of a unique opportunity for the government in the U.S. to take a strong stance and encourage consolidation around common connectors. So be eagerly awaiting that announcement.
Great, thank you. Can you talk a little bit about charging stations that incorporate batteries to avoid the demand charges? And if you think we will be seeing more of those?
Well, it's a good question. We talked a little bit about the motivation to co-locate storage with charging a little bit ago, helping smooth out load and lower demand charges. From say policy to help with the affordability and profitability of these DC fast charging stations. So some of the options that have been considered right now are things like a demand charge holiday, where say for the first 5 years of operation, the electric utility would waive any demand charges from the station owner operator while they were able to build up more of a base and have some level of demand that they were able to amortize those costs over. So that they could support demand charges at some point. There's also talk of developing what are called volumetric rates, or specific tariffs for charging network companies that don't have this demand charge feature to them, but really try to structure themselves in a way where all of the fees that you have, not only for the fuel, the electricity that's provided, but also for the maintenance of the distribution hardware, is set up to be recouped by the utility per kilowatt hour of electrical load. And so some of those policy solutions could really mitigate the amount of or the need that the industry has for on-site storage. But it'll be interesting to see what directions different states go with regard to those policy decisions.
So there's been some chat about using the VW settlement money along Idaho's designated EV corridors, which are mostly our interstates, but also some questions in the chat about what about, for instance, in Idaho, where we have these smaller north-south highways that are in largely rural areas, and is there financial assistance for those, not only for the stations, but for technology help, maintenance and service help, kind of that ongoing need, as well as just an installation?
Yeah. So I think the maintenance and the operating expenses of these stations is a really critical part of the puzzle, right? So the legislation, the bipartisan infrastructure law, actually has some provisions in it to help support and finance the operation and maintenance of stations that are installed under either the National Formula Program or the forthcoming National Grant Program, both of which are going to be administered by US DOT. So looking forward to see more details on those, including what elements are going to be considered eligible and ineligible expenses when it comes to operating. But like I said, I think having the stations be something that people can count on and are available and in good service when you arrive is critical to the success of not only the charging industry, but really the larger electrification movement.
And I misspoke earlier. I misread one of the chats that those smaller north-south highways are part of that EV corridor plan in Idaho. I misspoke on that reading through the chats. Also, just a question about fire risk when charging.
Is that the question?
Yes. Is there a fire risk when charging?
You know, it's something that has been pretty rare in general. So the equipment that is installed at these stations is and should be you know, certified for outdoor operation. You know, have automatic disconnect in the case of a fault or anything abnormal happening during the event. So we typically see these as very safe stations and interactions. Certainly a lot of power, but the engineers that have developed the hardware, I think, have done a really good job ensuring that, you know, there's very minimal risk for exposure to the electricity that's being provided to the vehicle. Now that said, there has been some challenges from a handful of the vehicle manufacturers with battery fires. This hasn't so much been the case at public stations, but actually has been a challenge or a problem, I should say, with vehicles charging overnight at home. You know, the absolute number of fires has been relatively small, and to my knowledge, that there has not been any loss of life that has resulted from those fires. But you know, a black eye for the industry nonetheless, and a technical challenge to overcome. You know, a lot of what you'll see with those battery fires is what's called an internal short circuit within the battery, and essentially it results from a manufacturing default when the battery was manufactured. And so there's a lot of work going in right now to ensuring that when these vehicles are sold to consumers, that they are safe devices, and that there's the ability to isolate any of those internal short circuits if and when they do happen, so that it doesn't result in a loss of the battery or a fire, you know, as I'm describing.
And then looking kind of towards the future, how likely is the highway charging being via oscillating electromagnetic fields?
Ooh, there's a good one. That's a good one. Yeah, so in motion wireless charging is very much still in the R&D space, I would say, right now. So the idea, right, for those that may not be familiar, is that you could install a series of inductive pads in a highway, say in maybe a designated lane or something. And if you were driving over those pads, you could have a receiver on the bottom of your vehicle that would catch that magnetic field and be able to use that to charge the battery while you're in motion and driving down the highway. It's really exciting technology. I think, you know, often what you find with infrastructure deployment is that you'll run into this chicken and the egg issue with what comes first. And you know, in order for something like that to really be attractive for the industry and for consumers, I think you'd have to kind of have this all-in attitude, right? You know, just having isolated or segmented stretches of highway with this feature, you know, might not be enough for a consumer to say, yeah, I'll pay an extra, I don't know, $2,000 to have this pad installed on the bottom of my vehicle to catch that electricity. So you'd really, you know, if you're going to do it right, I think you'd have to have a very aggressive deployment where the technology was available on vehicles, but also broadly across the U.S. highway system. And that's really going to be a challenge. You know, I think the cost of that infrastructure really, you know, makes these inductive or these conductive or stationary charging stations look much more reasonable, actually. So I'm a little bit pessimistic personally on the deployment of that infrastructure, but it is exciting technology.
One more question now related to something you were just talking about a moment ago, and then go back into your comments. And that goes back to the discussion about fire. So can you comment on the status of solid state batteries, which are more resistant to fire?
Yeah, so solid state batteries have mostly been in the R&D space to this point. Almost everything that's been deployed in a commercial grade application or for available for consumers has relied on lithium ion. Solid state is not the only battery technology that's being explored right now for the next generation of vehicles. There are others that the electrochemists are looking at, and so the challenge that you tend to find with batteries is that from an engineer's perspective, the design requirements are high and multifaceted. So they're under pressure to produce batteries that use all of the right elements. So they're kind of constrained politically in that way. So the right elements, they need to be safe, they need to last a long time, they need to be cheap, and they need to be very energy dense. And so when an engineer looks at all of those requirements, that's a really challenging problem. And luckily, though, we've got some of the brightest minds, I would say, in the country right now working on electrochemistry and developing the next generation of battery technologies. And so it'll be exciting to see what commercializes from that and what the kinds of products that are going to be available to consumers as a result.
Okay, thank you, Eric. Before I punt it back to you, just a reminder to everyone, if you have not completed the poll on your screen, we would really appreciate it if you would do that. It helps us out and make sure that we are reaching everyone in the Valley. With that, Eric, I will turn it back over to you.
All right, great. Yeah, so we did some kind of 101, I think, for the infrastructure and the technology itself. I wanted to take a look at the status of the national network today. So there's been a tremendous amount of infrastructure that's been installed over the past decade. We're actually north now of 100,000 publicly accessible charging ports. Again, a port is a piece of infrastructure that can charge one vehicle at a time. The majority of that infrastructure has been AC or alternating current level 2 infrastructure, so the relatively slow charging. But we're at about 20,000 fast charging ports nationally, with about a 50-50 split between the Tesla supercharger network and the rest of the publicly accessible infrastructure today. So despite having made so much progress, you look at this map and you still see huge gaps, especially west of the Mississippi, regarding the coverage for infrastructure. So kind of going back to that coverage versus capacity idea, a lot of this infrastructure has been installed in cities where there's the most potential for it to be well utilized and for it to be profitable for the companies that install it. But the challenge that we're looking at today is really trying to make the infrastructure more widely accessible, get it available in more rural communities, not only for encouraging folks that live in those rural communities to adopt, but also for making those communities accessible for all of the people living in city and urban areas. Whether it's the cross-country road trip, the vacation, or visiting relatives and friends and family. These are the kinds of trips that we know don't happen with a lot of regularity necessarily, but can make or break the decision on whether to adopt an electric vehicle. So we'll just take a little bit closer look at the area in and around Idaho. So I would say good coverage right now, along the interstate network. Electrify America and Tesla both have made investments along the various interstate corridors in and around Idaho to enable that mobility, as the question was posed a second ago. But then if you get off that interstate network, you find much sparser access to charging, with a lot of the charging concentrated in cities and urban areas. The map on the screen now is using two marker types to reflect two types of fast charging stations. The maroon or red markers are DC fast charging stations, most of them rated at a 50 kilowatt level. These are really historically, what we've seen deployed, over the last decade. The green markers are what I would call maybe a modern fast charging station. So these are stations with multiple ports rated at 150 kilowatts each. And so this is really getting to the point where you can charge an electric vehicle, say in 30 to 40 minutes, depending on the size of the battery. And so this is starting to become more competitive for folks that are looking at making long trips and may not really have a lot of desire to sit and wait for their vehicle to charge for a long time. So again, good coverage on the interstates, still a lot of work to do on some of the north-south routes through Idaho as the question was posed. Some quick stats on Idaho. So there are about 2 million registered light-duty vehicles in the state currently, and about 1,000 gas stations. It can be tempting to look at those two numbers and try to say, what's the ratio of gas stations to vehicles, and use that as a planning tool for EVs. The challenge is that most people cannot, refuel their gasoline vehicle at home today, and are completely reliant on public stations for gasoline or diesel. The opposite is true, though, for the deployment of EVs and charging stations. So a lot of charging today does happen at people's private residence and at home. And so it's really the public network that's helping bridge the gap, either for people that don't have that residential access or for people that are trying to take their vehicle far from home on a long road trip. And so the kind of planning philosophy is just a different one when it comes to EVs. And so our latest data on Idaho has about 6,000 plug-in vehicles registered in the state, including plug-in hybrids and battery electric vehicles. About 100 publicly accessible charging stations today, with about 260 public charging ports accessible today. So I've got kind of another section coming up here that's going to dive more into some financials, but I'll just pause quick, Amy, if there's anything I can cover from the questions.
So just a question on your numbers. It asked how you got the 100 charging stations and 260 charging ports in Idaho, where that information came from.
Yeah, so the Department of Energy maintains a website that is a warehouse essentially for this information on alternative fueling infrastructure. And so that if you Google the Department of Energy Alternative Fuels Data Center, or AFDC, there's a tool there called the Station Locator, where you can map out charging stations as well as other alternative fuel infrastructure and view the location and some limited attributes for those stations.
Just two other comments in the chat. One, that there is one additional charging station in Huntington, Oregon that is currently not shown on the map. And also just a comment that you talked about 30 minutes to charge, that one of the considerations needs to be, what do people do during that 30 minutes? That there needs to be some facilities provided for people to be able to have something to do during that time to make those charging stations attractive.
Absolutely, yeah. So a quick clarification on the map. We're only showing DC charging stations or fast charging stations on the map. So if it was a level 2 station that was missed on the map, that could be why. If there's a fast charging station that is not on this map and anyone thinks should be, please put some details on that in the chat for me, and I can follow up with the AFDC team and see if there's a way we could get it added to the database. The database is a combination of automated data collection and manual data collection, and so there are missing stations from time to time that we'd love to be made aware of.
Great. I will watch for that in the chat and pass that information on to you, Eric, if
yes.
And with that,
the comment about amenities is super important. So I just want to emphasize that. The commenter is absolutely right. When you stop somewhere on a road trip in particular, there needs to be something there to do. The area needs to be safe. It needs to be well lit. Ideally, there would be amenities, somewhere to go to the bathroom, somewhere to get something to eat, within walking distance, preferably. And so these are all considerations or best practices, I would say, for site development, including in addition to things like having ADA accessible stalls at the charging station, and increasingly as we think about things like electric pickup trucks, developing sites that have drive-through charging. A lot of the stalls you see today are back-end stalls So if you imagine someone pulling in with an electric pickup truck and a trailer, for instance, it's really going to be a pain to unhitch and have to back in your truck for a charging station. So pull through, similar to what you see at most gas stations, is kind of the another level of maturity that I think the industry is beginning to observe.
Great, thank you. I will turn it back to you, Eric.
Sounds good. All right, so kind of glib here. Show me the money. This is probably one of the most frequent questions, right? For what do these things cost? And the answer in many ways is that it depends. So what we're showing on the slide here are some estimates from public sources on the hardware costs and the installation cost, both of which are normalized per port for different types of charging. So we're showing level 2 commercial installs here. So these are like on the order of 6 to 7 kilowatt installs typically per port, all the way up to 350 kW DC public installs. Now, if you look on the low end, right, you can see that in the right circumstance, you may be able to procure, a level 2 port for as low as $1,600, and have an installation of just a little bit less than that, and walk away from the whole thing, below $3,000 of investment. So that doesn't sound too bad, right? But that's a really kind of limited piece of infrastructure, a single level 2 port. What we're seeing, as being more useful and what's really needed at this point in the industry are what I would call modern fast charging stations. So these would be 150 kW ports at a minimum, I would say, where you've got several of them at the site for some level of redundancy. And so if you're thinking about a multi-port site with 150 kW capability per port, it's not hard to get up to $1 million of capital expense looking at the hardware and the installation. In particular, those installation costs, as you can see in the table, vary dramatically, right? So as low as $34,000 per port, up to $131,000 per port. There's a lot of factors that go into what those installation costs look like, including if any concrete needs to be trenched and broken up in order to run the conduit from the on-site transformer to the charger itself. How much retrofitting needs to be done, whether a new transformer may be necessary. Are you going to install on-site storage or generation at the site? And so there's just many things that make these costs difficult to generalize and estimate. The actual cost is really going to depend on the configuration of the site that's being developed and the location or the amenability of the site to facilitate that charging. As we look into the future, I think there's some room for optimism on the cost front. As we see more of these units manufactured, I think there's potential to benefit from that manufacturing scale and kind of come down on the learning curve a little bit. The learning curve also applies to the installers and the installation costs. So as more of these sites are developed, there's potential for efficiencies of scale and best practices to be developed. On the other side of the coin, though, we know that there are a lot of sites that have been developed today specifically because there was an on-site transformer with the proper rating and there were amenities. And so, Electrify America, Tesla, some of these companies have gone out and developed a lot of what I would call the low-hanging fruit already today. And so as we look to continue and grow the network, finding sites that have the adequate facilities and equipment to support charging could be more challenging. Excuse me, guys. This is a lot of talking for me, so I've got to keep up on the water here. All right, I'll go a couple more slides on costs, and I imagine there'll be some questions on this topic. So, we've talked about it already, but utilization is key for the companies that try to own and operate this equipment. And when you think about utilization, it's a little bit of a double-edged sword for these companies. So on one hand, they want the station to be busy, right? They want the station to be selling electricity, to be drawing in customers to the site for other retail activity, perhaps. But on the other hand, if the site is too busy, right, that means that you're getting lines, you're getting queues, people are becoming frustrated, and you're negatively impacting your customer experience. And so it ends up being this balancing act for the charging companies, where they want to make sure they've got enough infrastructure available for a positive experience and to avoid people waiting in line. But getting too far ahead of demand, so to speak, can also be challenging. If you've got underutilized assets that have been invested in and that are in the ground. The slide here shows some public data that's been made available from Electrify America, looking at various highway corridors where they've developed stations and what some of the utilization rates are. There are some decent corridors out there on this slide, but in general, a lot of the corridors are seeing very low utilization today, which really is a symptom of the infrastructure being deployed intentionally to try and lead the vehicle market and help develop that consumer confidence that I can go out and buy an EV, and I know there's all these stations that have been installed primarily along the interstate network today. So in addition to the more tangible costs of the hardware, the construction and installation, there's been a lot of discussion in the industry about the role of soft costs. I really want to credit here a Rocky Mountain Institute study from 2019 as being really the work that highlighted the role of soft costs in making deployment of this infrastructure much more challenging. Some of the charging providers that were surveyed in this report actually cited that the most significant cost driver in their deployment was not the hardware or the installation itself, but all of the procurement challenges, the approvals, the utility interconnection. So approvals that should only take by law 15 days in California, for instance, taking an average of 79 days. Utility interconnection processes that were expected to only take a few weeks, taking almost a year on average to energize the site and bring power out to a location. So these soft costs are things that delay the energizing of a site or the opening of a site that's otherwise constructed and ready to go, are something that's really been a thorn in the side of these companies, and has made their operations much more expensive. So to the extent that approval processes can be standardized, and utilities and public agencies can anticipate these kinds of permitting requests and have well-defined and efficient procedures for the charging networks to engage in, that could go a long way to help bring down some of the cost of this infrastructure. So I'll go ahead and pause there again, Amy.
Great, thank you, Eric. Going along with what you were talking about the costs and other things that you have mentioned earlier, of different obstacles to implementing EV infrastructure, what do you really see as the biggest ones? What are the primary obstacles?
Oh gosh, yeah. So the problem is there are many obstacles, right? It's a challenging industry. We've talked about demand charges. We've talked about the high capital costs, reliability, and these soft costs. I'm not sure if I want to call the soft costs the most challenging piece of the puzzle, but it's one where it seems like there's really potential to make an impact, right? So if as an industry and as a society we're motivated to develop this infrastructure, I think prioritizing efficient permitting processes and utility interconnection processes is something where as an industry we could really make a meaningful difference for these companies, and help reduce some of these hidden or soft costs as the RMI report lays it out there. Again, policy action on the utility regulator side, to help these companies deal with demand charges. That's another one that I think is ripe for attention. And then luckily the industry is on the edge of having access to a tremendous amount of capital through some of these federal programs as part of the bipartisan infrastructure law. So there's kind of a path there for some help on the financing side, but soft costs and demand charges, I think, have good opportunities for improvement.
Are the challenges related to the permitting delays, are those more kind of government, more city county requirements that are causing the delays, or are those more the utility companies?
I would say both in general. The problem is that there's thousands of electric utilities right across the United States, and for a company, a national company like ChargePoint or EVgo that is trying to develop sites nationally, they end up having to conform to so many different types of approvals processes. So if there was a way, right, that we could standardize as an industry, what the approval process looks like for the utilities and for the city and state government and municipal organizations to install these pieces of infrastructure, I just see a lot of potential there to improve the situation. And it's really just a matter, in my mind, of finding ways to standardize the process, which I make it sound easy, and I know it's not. But having so many different kinds of processes and hoops to jump through for these companies is a challenge. And in some cases, there's not even dedicated staff, right, at a small electric co-op or utility for approving these kinds of interconnection requests for EV charging. And so even things like making sure that there's staff dedicated and the organization is set up in a way where we're anticipating these companies coming in and wanting to install this infrastructure. That's a big piece of the puzzle, right? If this is all supposed to scale and we're supposed to go from 2 million vehicles on the road today to 30 million vehicles on the road in just a few years, achieving that scale and some efficiency in the deployment of infrastructure, I think is critical.
I have several questions. I'll kind of ask them as a group, and then you can break them down. I'll deal with cost and estimating and who pays for them. So all interrelated. One, really who should be paying to make this happen, with a suggestion, should this be essentially a national utility? And then a related question, what about commercial businesses, a grocery store that has a charging station, and how are those rising to the occasion? And then a somewhat related but slightly different question, but also dealing with costs, is are there estimating tools out there that, for instance, a small city could use to have an understanding of what this might cost them, so they would know, moving forward, kind of short-term costs, long-term maintenance costs? And are there tools out there to help estimate that?
Yeah. So on the tools front, there's a couple consulting firms that have done some work in this space. So MJ Bradley and Associates has a suite of EV infrastructure planning tools, as does a company called Atlas Public Policy. So I direct folks to take a look at what they have to offer. And then some of the reports that I've cited here include information on publicly available data on the cost to deploy this infrastructure. I think the maintenance cost is one, like I said this a little while ago. Historically, I think it's probably been undervalued or underinvested in, but that's one I think at the beginning of life, or when the station is brought online, is something that needs to be planned for up front, right? We don't want these stations operational for just a year or two until something breaks, right? We want them available 10, 15 years or more to continue being valuable and providing this service to the transportation system. Okay, so that was on tools. What was right before that, Amy? Can you help me out?
A combination of really who should pay. Should this be businesses or federal or something in between?
Well, I tell you what, guys, there's a lot of experimentation going on right now on business models for this industry. So you'll see a lot of different pricing schemes or subscription models. That experimentation really suggests to me that the industry doesn't entirely have a clear path to profitability here, right? So one model that makes a lot of sense to me is charging as an amenity for a customer, or something to draw a customer into a store. So you'll see that, you know, at a lot of Targets and Walmarts around the country, different charging companies have agreements there to bring their services in and make charging available for those customers. Now, currently, it's unclear, you know, what the agreement between the charging company and the site host looks like. So in some cases, it may be that the site host is subsidizing the charging company and attracting them to their location. In other cases, it probably works in the opposite way, and maybe more commonly in the opposite way, where the charging company is actually leasing the property or those parking stalls and the land where the charging infrastructure is located, so that they can provide that service to the customers of the site host. But again, it's all evolving still, and so part of the challenge here is that all of this really hinges on utilization of the infrastructure. And so you know, I think the industry needs to be out in front in order to support, you know, vehicle adoption, but they're also going to suffer as a result of trying to build ahead of demand. And so as the size of the fleet increases in different cities and states, hopefully we'll see more of these stations being viewed as profitable investments for the charging companies. I'm not sure I totally answered the question there. So who should pay? There's not a clear model right now. And so what you're seeing is investment from a lot of directions, right? So there is private investment that's happening, both the charging companies and the site hosts in some cases. Public investment, certainly, from state and local governments, most notably the big $7.5 billion you know, law from the federal government, as well as from electric utilities, right? So there's been a big push for utility investment in what are called make-ready programs. So these are programs that are designed to try and make sure that there's all of the necessary pieces in place for a charging company to come in and actually install that charger. So having an appropriately sized transformer ready, making sure there's line capacity upstream to support the station. These are all the things that the utility is trying to do in certain cases and programs to make sure that EV charging installations are you know, ready to go, right, and kind of pre-building sites for these companies.
So there's a question on just trying to better understand the utility interconnect process, the 273 days, and also another comment in the chat pointing out that was a California figure, not necessarily Idaho, and not necessarily a national figure. But if you could just clarify what exactly that means. Is that essentially from start to finish, design to opening, that it's the 273 days, or what exactly that means?
Yeah. So that should be when the utility has been contacted or a request has been made for new electrical service at a location. From that time until the day that the site has been energized and actually has power available to charge vehicles.
Thank you. Next question is, doesn't it make sense to just have ChargePoint or Electrify America be responsible for all of the maintenance?
Sorry, I didn't quite catch all that. Can you repeat that, Amy?
Yes, doesn't it make sense to have a ChargePoint or Electrify America be in charge of all of the maintenance?
Yeah, potentially. Like I said, I think you know, the business models are evolving. I think the fear is that, you know, public funding can be you know, stranded or you know, misallocated if there is not a guarantee of some kind that the grant recipient has a requirement to maintain and operate that station, right? If we're only, you know, handing out money, so to speak, or incentivizing installation of these stations, but not requiring anyone to be accountable for the operation and maintenance of the station, I think that's a flawed system, right? But The levers at our disposal are a little bit limited, right? Just given the financial challenges that the charging companies face.
That is all the questions in the chat now. I will remind people, if you have not completed the poll on your screen, to please complete that before the end of the presentation, and I will turn you back over to Eric.
Okay, Amy, and then maybe a quick time check. So I think we're almost an hour and a half in here. We're scheduled to go to 3 Mountain, is that right?
That is correct.
Okay, cool. So I've got a fair amount of content still, but it's been really good back and forth, and so I think that we've been spending our time well. I'll try to get through the next section relatively quickly if I can. So measure twice, cut once. So at NREL, we've been fortunate enough to have support for at least the last decade to develop a suite of planning tools oriented at deployment of charging infrastructure. And so we've kind of labeled these tools our EVIX suite, or our electric vehicle infrastructure planning suite. So these tools include both network design tools to try and answer questions about how many ports might be necessary, what kind of ports, where should those be located. Our site design tools really look at individual locations and try to enable what-if analysis or trade-off studies, looking at presence of storage or on-site generation, what the load profiles might look like in a given location, and what trade-offs between queuing and station size might look like. And then all of these tools can be wrapped up in financial analysis to look at the levelized cost of charging, and try to understand what the expense is going to be to install and operate a network. This, like I said, these tools have been developed over many years at NREL. I've certainly been involved in a lot of this, but there's a relatively big team that is behind all of this, and so I just wanted to acknowledge all the great people at NREL that I've been fortunate enough to work with over the last decade. And truth be told, this is really just a small number of those people, but some of the PIs on tools that were shown on the previous slide. So perhaps our flagship tool for network planning is EVI Pro, or the Electric Vehicle Infrastructure Projection Tool. This is a simulation model that has been developed as a two-step model that first tries to estimate the demand for charging from electric vehicles using a simulation-based approach, and then attempts to design a supply of hypothetical infrastructure that would be capable of meeting the simulated demand. This model is informed by real-world data to the greatest extent possible, and has also been integrated with models regarding vehicle adoption, electric mobility, station economics, and the grid. The model was originally developed for the California Energy Commission, but has since been applied at the city, state, and national level for a host of geographies. The model relies on relatively detailed travel data from travel surveys, as well as instrumented vehicle GPS data, to understand what the opportunities for charging look like. How much time do people spend at different locations? What time of day do they visit? How much are they driving? This helps really inform the way that we model energy consumption in these vehicles and anticipate what the need for charging might be. So within EVI Pro, we're able to take these detailed travel schedules, an example of which is shown on this slide, where an individual makes 4 trips during the day at different times of day, and has the option to charge in different ways throughout the day. So we're showing an example here of someone that charges every night, and it doesn't really need to rely on public charging. Someone that plugs in at home, but only when they need to, only when they're getting low, and might occasionally make use of charging away from home. And then we also simulate someone that does not have residential access and is completely reliant on public infrastructure. The plot on the slide shows those 3 battery state of charge traces across a 24-hour period for this hypothetical vehicle. So what we try to do with the model then is repeat this process over a large number of combinations of vehicle technology and travel behavior to try and anticipate what we think charging needs might be, both at home, workplace, and public locations and then use this model as a way to inform planning efforts at either a city, state, or a national level. One of the biggest inputs in EVI Pro is the number of vehicles that we assume have access to home charging or residential charging. And so we actually spent quite a bit of time over the last few years conducting a national survey, asking people, what we think are actually pretty basic questions. So some of which are things you can find in the census, like, where do you live? What kind of house do you live in? Do you own or rent? What's your household income? So a lot of, general census type questions. But then in addition to those, we asked them, how many vehicles do you own? Where do you park your vehicle at home? And for each of those parking locations, what is your current and potential access to electricity in those parking locations? So this kind of mundane information on where people park at home and access to electricity is relatively absent from public data and from the academic literature. And so we think this survey has been really valuable in trying to help us develop scenarios for what future access to residential charging might look like. And in general, it's kind of our belief that a lot of the people that own and drive an electric vehicle today do have access to home charging. And there's been a little bit of a selection bias in that way that if you don't have that residential access, you're less likely to adopt. And so when we talk to people that are interested in understanding, well, what would it look like if 50% of new car sales were electric, or if all the cars in the U.S. were plug-in electric vehicles, this is the kind of data that we use to say, well, in really aggressive scenarios, here's how many people we think may have access to charging at home in those really aggressive scenarios, based on the way that people are parking and behaving at home today. And so in general, we would forecast that residential access will decrease as the size of the plug-in market increases. But there's a lot of variation within these scenarios, depending on what level of education goes into informing people about the role of home charging, how much investment goes into residential access, including at multi-unit dwellings, apartment buildings, as well as at single-family homes. And then how willing are people to be flexible, regarding the location that they park at when at home, in order to facilitate charging one or even more than one electric vehicle within a given household. So all of these kind of capabilities are available online for EVI Pro in a simplified format. So this is a site on the AFDC, or the Alternative Fuels Data Center. We call it EVI Pro Lite. And there's a couple of different tabs that allow you to do both needs analysis for infrastructure as well as load profile estimation for grid integration based on the EVI Pro tool. So the Lite tool has a simplified user interface and really, does not require much information to run. We simply ask for information about the geography of interest, either a city or a state, and the size of the fleet that you're interested in studying for that location. Based on that, we'll make some estimates for the quantity or volume of workplace, level 2, and public fast charging infrastructure that we think might be necessary to support a fleet of that size in a given location. The tool also exposes a number of key variables, including residential access, vehicle technology, as well as charging behavior variables, so that you can kind of run a stock scenario, a baseline scenario, or explore your own scenarios and try to customize for the region of interest. The tool's been used relatively extensively, so it's got over 14,000 page views over the last couple of years, and people are engaging at a relatively high level with it at about 4 minutes per visit, which for the internet turns out to be pretty good. So quickly just want to acknowledge the elephant in the room, right? So there's a lot of work going on EVs, and we've been talking about that. We really haven't talked about driverless technology, right? Or cars that drive themselves. And so there's a lot of investment and excitement right now about this kind of technology. The image here is from a company called Waymo, which is a division of Alphabet or Google, that's really been one of the leaders in this area. The vehicle in the picture there is on the highway, without a driver in the seat, doing some testing. So it maybe goes without saying, but I'll do it anyway, I guess. This kind of technology really has dramatic potential to affect the way that we move and the role of vehicles in our lives. Vehicles today spend 95% of their life parked, not moving or going anywhere. But a fleet of robo-taxis or driverless taxis, could be operated very differently, and really change the way we think about designing and using vehicles for our common mobility. And so, a lot of the work that we do thinks about real world data and traditional driving and ownership paradigms, but just a quick comment about the disruptive nature that this kind of technology could present. I'm going to go a couple more slides given time, Amy, and then we'll do another pause for questions. So I want to give a sneak peek, I guess, on some of the modeling that we're doing for the Department of Energy at the national level. So this is what we're calling our 30 by 30 study. 30 by 30 is kind of stealing for the 30 for 30 documentary platform on ESPN, but it's motivated by the fact that what would of trying to envision a future in 2030 where there were 30 million electric vehicles on the road. This is relatively consistent with the president's executive order on 50% EV sales by 2030, which a lot of the manufacturers are co-signing that kind of a goal. So what kind of infrastructure might we need to support that volume of vehicles on the road just a few years from now, right? So this is our national picture for adoption. Here we're showing a bunch of circles representing urban areas and cities and towns across the country. The size of the circles denotes the size of the plug-in vehicle fleet that we're assuming in 2030. And so in some parts of the country, say, around San Francisco, we're looking at up to about 50% of vehicles on the road as potentially being electric vehicles in 2030. Whereas, if you want to contrast that and go to rural North Dakota, we're assuming maybe 1% of vehicles on the road as electric vehicles in this 2030 scenario where we've got 30 million vehicles on the road in total. So this is kind of what the national picture looks like. We're using some of our modeling tools to try and estimate what the demand for charging would be on a daily basis, as well as for long distance road trips. This map comes from our EVI road trip model, and the markers here are showing locations of simulated charging events in the model supporting about 250,000 daily long distance road trips in electric vehicles across the country. So this considers, if we've got 30 million vehicles on the road, a lot of those are not going to be taking long distance trips every day. So we're using the best available data that we have from the Federal Highway Administration on long distance travel and these driving events in order to build up these kinds of models. So the sneak peek that I wanted to show you guys were some preliminary results for Idaho. And so on the left, I'm showing a kind of a column of intermediate results for the year 2025. On the right, we're looking at 2030. I'll go ahead and just narrate down the 2030 column here. So in the state or statewide in Idaho, we're looking at about 150,000 plug-in electric vehicles by 2030. These would be about 12% plug-in hybrid in our primary scenario. That's just a hair higher than our national average of 10% for plug-in hybrid by 2030. This would represent almost 8% of vehicles on the road as being a plug-in electric vehicle by 2030. So that 150,000 would be out of about 2 million vehicles on the road currently in Idaho. We're simulating Idaho with about a 91% level of access to residential charging. So the majority of vehicles we're simulating as having access to home overnight charging in Idaho, even by 2030. And what we result then with is about 4,000 publicly available charging ports being necessary to support demand in this scenario. That includes workplace level 2, publicly accessible level 2, as well as fast charging ports to support long distance travel and daily travel in the state. So that compares to about 260 installed ports today. So a dramatic increase, particularly I would say for the fast charging infrastructure, the high cost fast charging infrastructure. And then about 50% of the vehicles and the infrastructure in this scenario are located in the Boise metro, relative to the rest of the state. That's based on kind of adoption trajectories that we've seen currently, with a lot of electric vehicles primarily being adopted in more urban areas. So hopefully that's interesting or useful in some way for this audience, but happy to take a break here and answer any questions.
Eric, a question directly on what you were just talking about is, what are these projections based on? It says if we think Idaho will go from 6,000 to 150,000 EVs in 6 to 7 years, how will this level of EV infrastructure be completed by then? It seems unrealistic.
Yeah. So the modeling exercise that we're doing here is to take the goal that's been laid out at the national level and actually try and pencil that out for every state in the country to say, all right, if we're going to meet this national goal, which is an aggressive goal, I'm not going to argue with anyone on that, for 50% sales by 2030. Here's what we think the picture looks like in each state, and this would be kind of a look at what the picture would be in Idaho if we were able to meet that 50% sales goal. So 150,000 plug-in vehicles, that gets calculated based on the number of vehicles registered in Idaho today, as well as things like how many hybrid electric vehicles, including like a Toyota Prius, have been registered in Idaho, as well as how many electric and plug-in hybrid vehicles have been registered in Idaho to date. So that's kind of how we get to some of the vehicle numbers. Based on the size of that fleet, we then simulate, the driving of 150,000 vehicles in Idaho based on EVI Pro and EVI Road Trip, again using data from Federal Highway on how many miles are accumulated in these kinds of vehicles. And then based on how many people have access to residential charging, we're then able to model or simulate for that 150,000 vehicles, where is everyone charging? And so in order to have 150,000 vehicles on the road with 90% residential access, we're estimating about 4,200 publicly accessible ports to support that. So that's not to say that 4,200 ports 8 years from now is a reasonable estimate necessarily, but it tries to put some of the national goals in context at a local level is really our goal.
A follow-up question, what about commercial vehicles? It says it seems that none of the models and projections address commercial trucks. It would seem these numbers are low estimates for charging and highway needs if we include commercial vehicles.
Yep, that's right. I was going to talk about trucks in a slide, so just a little premature there. But yeah, this is all light duty. That's really, I think, the focus of a lot of the industry right now. There's potential, I think, for heavy truck electrification to happen even faster than light duty. So people that buy light duty cars, that's often what I would call an emotional decision on what kind of car you buy and what color it is, how many cup holders, that kind of thing. But when fleets of commercial vehicles are purchased, there's a lot more effort put into what's the ownership cost of that vehicle. And one of the selling points of electric is the lower ownership cost. And so to the extent that the price for heavy vehicles can come down far enough to where when you factor in the operational cost of a heavy duty EV. The point I'm trying to make, and I'm rambling, I apologize, is that there's really potential out there for heavy duty adoption to happen even faster. Now, in the early days, it's likely that most of the heavy duty charging would actually happen at depot facilities and overnight facilities. This is akin to what you see in the early days of light duty EVs, where most charging was happening at home. Because really the technology that's necessary for public charging of heavy duty vehicles is still under development. So the MCS connector, or the megawatt charging standard, is really what's going to be necessary, for a long haul truck to be able to pull into a truck stop and get out in less than an hour with a full charge. And that charging technology is still being developed. Like I say, heavy duty is also interesting because it's much more competitive right now between electric vehicles, hydrogen, and other low carbon fuels. It's not obvious right now in the same way that some would argue it's more obvious for light duty that EVs are the future. It's not nearly as obvious that EVs are the future for heavy duty trucking.
How do you see the overnight and L2 daytime charging impacting demand curves for the electric utilities?
Yeah, that's another one that I've got some slides on in a minute. I'll make a note here right now. So we would believe, based on the work that we've done at NREL, that the vast majority of charging is going to continue to be at home. That's really going to be the focus of the national network, is all the charging that happens in driveways and garages while people are sleeping primarily. And we know from the work that we've done to date that there's a tremendous amount of flexibility for load at residential locations. So for instance, if you're a 30-mile-a-day commuter, you might only be looking at, say, 8 to 10 kilowatt hours of load per night if you're plugging in every night. And on a level 2 unit, that's maybe an hour and a half of charging, right? So if you need to charge for an hour and a half, but you're at home for 12 hours, that could happen immediately when you get home at 7 o'clock at night. You could wait until midnight. You could even wait maybe until an hour and a half before you leave the next morning. And so utilities right now are very interested in developing programs to either incentivize charging at favorable times of day through things like EV specific rates or time of use pricing, or actually, looking at something closer to a demand charge, a demand response program, where they could actually have the ability to control charging for vehicles based on the real-time conditions of the grid. It's not clear to me what level of sophistication is going to be the right balance between cost and complexity for the utilities. But there's a lot of load flexibility for overnight home charging, and that's where a lot of the load is going to be, we think.
So Eric, it sounds like a lot of our questions are about things that you were about to cover, and it is about 10 till. So I'm going to cut off questions there and let you finish with your talking points, because it sounds like you're going to cover a lot of what people are asking about anyway.
Okay, yeah, I'll just make some quick comments here. So in the heavy duty space, the real front runner has been the transit agencies. So transit buses turn out to be a very well-suited use case for EVs. They tend to be high VMT or accumulate a lot of miles, but on fixed route operations that return to base every night. And so electric transit buses are able to take advantage of the low operating costs of EVs, and the predictable schedule alleviates the need for a lot of expensive fast charging. And so they've really been early adopters, and we've seen really dramatic adoption in this space. But overall, it's not a huge industry in terms of energy or miles driven in the U.S. for transit buses. The big one we think is really going to be semi-tractor trailers. So NREL is currently involved in a multi-agency task force to develop the charging technology for these kinds of trailers, tractor trailers. I mentioned this a second ago, the megawatt charging standard or the MCS connector is really what is going to be necessary for those truck stop electrification tasks, looking at 1 to 2 megawatt levels of charging. The gentleman on the left there is actually doing some testing at a lab in NREL of that connector as part of an industry event. And then, of course, the Tesla semi-prototype shown there following some testing in Chicago. So some products, getting closer to market in this space, which is really exciting. We've also seen Tesla recently, kick off construction for their first electric truck stop. A lot of Tesla's incentive is actually based on being able to do their own operations on low cost electricity, and so they're pioneering, I would say, a lot of the vehicle and charging technology that's going to be necessary. But when we look at larger geographic scales, we're trying to use some of our modeling tools at NREL to try and anticipate or study what different network designs could be for large scale deployment of megawatt level charging. So the animation here is looking at a number of different scenarios that have been evaluated on the West Coast using our EVI Pro HD model to try and estimate cost, look at grid impacts, and understand what the investment need might be in order to facilitate electric trucking on the West Coast. Let's see here. Boy, I've got a lot of content still. I'm trying to think here if I should just race through it or if we want to have some discussion here. Do you have any preference, Amy?
We have not had any new questions since our last round. There are a few going back that I did not ask just because I thought you might be getting it to them later, but we have not had any new questions posted. Okay,
well, maybe I'll just keep going then and try to cover some ground. So we have spent some time today talking about demand charges, so I'll kind of skip over some of these. The one point that I'll make from this slide, I guess, is that demand charges in a low volume business can really just be a death knell for the company, right? So if you look at the effective costs that some of these companies are paying per kilowatt hour in low demand environments, they're easily clearing $1 or $2 per kilowatt hour. That's equivalent to north of $10 or $20 per gallon of gasoline, and so that's a very expensive fuel in a low demand environment. So you're just underscoring the significance of demand charges yet again. This is a map showing some analysis that we did looking at electricity rates around different utilities in the US and identifying locations where either a recommendation for on-site solar or on-site storage may make the most sense based on the solar resource, the demand that was simulated for the location, as well as the local electricity rates. We've talked about reliability. This is just driving home that point. Driver tolerance for inconvenience is very low. This was some industry interviews that we did recently. Even one negative experience waiting in line or finding a broken charger can sour a user on EVs. You don't have to spoil many Christmas trips to grandma's house in an EV in order for people really to be turned off by the technology. And so the reliability issue is just huge. And we know from user consumer experience surveys today that even the leading charging networks are really struggling with service, ease of payment, having a reliable product that people can easily understand is really a challenge for a lot of these companies even today. Interoperability is another one, right? So there are a number of different gas station providers today and fuel providers, but you basically get more or less the same experience when you show up to gas stations today with a credit card reader or going inside to pay cash. That's really not the case with EV charging yet. Right now, there are a lot of networks that require subscription services in order to use their network or a dedicated app on your phone. And that's really not something that we think drivers are going to tolerate as the technology goes mainstream. So there has been some limited work for these agencies or for these organizations to develop roaming agreements or peer-to-peer agreements with one another, and kind of are looking forward to more of that as the industry continues to mature. Just some site design best practices. Location. Siting stations for demand is something that we can't emphasize enough. We described how the cost to develop a site really varies based on the characteristics of the site, and so it could be tempting to go out and say, let's find the lowest cost sites to develop and build a network that way. But in the end, if your utilization if the location of your site means that it's not attractive to consumers because of lack of amenities, or it's hard to find, or it's behind a warehouse somewhere, having a low-cost site isn't going to do you any good at that point if no one's using it. So really focused on the customer experience and trying to site based around anticipated demand, we think is really important. The need for future-proofing, right? So I've talked a lot today about 150 kW fast charging. That's kind of the state of a lot of the industry today, but there's a desire to go beyond that, right? And so if 150 kW sites are being developed today, having in mind, what it would look like if down the road the site was upgraded for 350 kW service, is really important. Not pouring concrete over conduit, making sure that there's ways that the site can be upgraded with low cost in the future as the industry continues to evolve. We talked a lot about storage and generation for operating costs. Payment is another one where standardized payment mechanisms across charging networks is really important. And reliability we've hit on as well. Maybe I'll just leave you guys with some of these maps here. So haven't really talked a whole lot about equity today. This is a map from Chicago, just highlighting the situation in Chicago. So the map here is showing these little green triangles for locations of fast charging infrastructure today in Chicago, primarily being located in affluent and high income areas and relatively non-diverse areas of the city, which in some ways makes sense, right? These are the people that have bought and are operating and driving electric vehicles today. But you can really see, these low income areas or more diverse areas in Chicago have been charging deserts, so to speak. So a real lack of investment in these areas. And maybe you look at that and say, well, there's lots of reasons why you might develop infrastructure in different locations. But if we bring in the gas station map, it's clear that access to gasoline or convenience stores has not been a barrier in some of these lower income neighborhoods, whereas access to EV charging really has. And so to the extent that public dollars are being used to finance charging stations, making them accessible and available to all communities, in addition to trying to take steps and make electric vehicles affordable in the secondary market, probably are ways that we want to think about equitable solutions for EV infrastructure. So I've exhausted the time here, Amy, but I'll go and just scroll to the end. Almost got through everything, but really appreciate the chance to visit with you guys today and all the engagement. It was a good conversation.
Great. Thank you, Eric. It really was. We've had a great conversation today. I really appreciate everyone's questions. I know we were not able to get to all the questions in the chat. I certainly tried to, but we had a lot of questions, a lot of great conversation. I will remind everyone that you'll receive an email from me as a follow-up, most likely tomorrow, with an evaluation requesting you to please complete that and send it back to me. It definitely helps me as I plan our education series. You'll also receive a link to a video recording of this that'll be posted on Compass's YouTube channel, as well as to Eric's slides that we will post on Compass's website. So you will be able to go back and refer back to all of those at a future point. So with that, I would like to thank you again, Eric, for some really great information. I think we've got a lot to think about and a lot to absorb. And I'd like to thank everyone who took time out of your day to join us today. And go ahead, Eric, look, I'm going to say one more thing.
Oh, no, just appreciate the chance to visit with you guys, and yeah, happy to follow up afterwards with any lingering questions.
Great. Thank you very much, everyone. Have a good rest of your afternoon.